Hello aspirants, we are going to study about cyclones, both tropical and temperate cyclone. We will also be covering anticyclones along with it. So this is basically for your attempt in 2026. So whatever slides we go through, like conditions of tropical cyclone, what is needed is for you to pause, reflect and see how much you remember already and how much you need to retain. This is a revision class for 2026. So let's see about cyclones here. So what are the conditions of tropical cyclone? Number one is sea surface temperature. The sea surface temperatures given in NCERT is 27 degrees Celsius. Now whichever website or whichever other books you follow says 25, 26, 26.5, doesn't matter. You will study NCERT. UPSC knows NCERT, does not know any other thing. So UPSC is 27 degrees Celsius, NCERT says 27 degrees Celsius, that is it, 27. Sea surface temperatures should be higher than 27 degrees Celsius. Next, what we need presence of Coriolis force. Why? Because the winds need to swirl around, they need to move around. So we need presence of Coriolis force. Third we need is small variations in the vertical wind speed. What is the meaning of this? Now you are going to attempt prelims, so think what can this mean? Small variations in vertical wind speed. It means that if there is something going on top of the cyclone, so we know the diagram of a cyclone, there are clouds here, there are clouds here and winds coming down. So the whatever is happening at the top, the wind speed at the top should be almost similar to the wind speed at the bottom. This is given exactly in NCERT. So winds at the surface and winds at the upper atmosphere should move at almost the same speed and direction. If this does not happen, if there is a difference in wind speeds, a massive difference in wind speeds, the cyclone will shear, that is, it will tear apart and dissipate right there. So winds at the entire column of air, this huge column of air, has to be same at every place. Not exactly same, there can be a bit of variations, not much. Number 4. So cyclones cannot happen anywhere and everywhere. A pre-existing weak low pressure area must be present. A pre-existing weak low pressure area. So we have different low pressure area troughs. You remember there is one trough in the Bay of Bengal, low pressure area trough. If you have studied Indian geography, you know which trough I'm talking about. There is this Bay of Bengal over here and there is a low pressure trough, and we know that ITCZ always has to meet this low pressure trough for an Indian monsoon. Now, during the months of October, November, we always get some sort of a cyclone hitting the eastern coast of India. Now, so there is always a low pressure trough present over the Bay of Bengal, and that's why it happens. Finally, upper divergence above the sea level system. Again, this is directly taken from NCERT. What does this mean, and why is there a chimney here? The reason is that at high altitude, air must spread outward. Look at this column. So there is cloud here, there is clouds here, cumulonimbus clouds forming everywhere, and when winds move up, they should not be blocked. They should have an opening to diverse. For example, like a chimney. When the chimney smoke goes up, it spreads across. If there is some blockage from top, then it won't happen. Then the chimney will get over. There will not be any fire remaining. So, at high altitude, air must spread out away from the cyclone top. It must be spreading out. There should not be anything which is stopping it. So these 4 reasons are given in NCERT. I would like you to go really deep into it, think about it. Geography is all about analytical things and thinking. Now let's get to the stages of formation of a tropical cyclone. First we have area of low pressure is created when warm sea air rises. Of course, warm sea air rises and low pressure area is formed. Once the low pressure area is formed, then winds from outside jet inside, and those are mostly cold winds. Next, what do we have is the presence of Coriolis force. Now, how does Coriolis force act? It is very hard for many people to understand that how Coriolis force acts here and how it forces winds to flow a particular direction. If there was no Coriolis force present and a low pressure area is over here, winds would just go directly from all directions. Okay, simple. Now, with the presence of Coriolis force, these very winds will just deflect toward the right. Just a small deflection. So, they are just deflecting to the right. This was the original path. This was the original path. They just deflected. All of them just deflected to the right. And they finally form a circular motion. And this is how a cyclone starts its first breaths. Now it is starting to form. This is happening in the Northern Hemisphere because winds are flowing in the anti-clockwise direction. That's why I've kept a clock here for you to understand that a clock flows in that direction. In this direction, when it does, it is the anti-clockwise direction, and that direction is followed in the Northern Hemisphere. In Southern Hemisphere, cyclone takes a different course altogether. Over there, the winds go in a clockwise direction. Now is warm air continues to rise, creating moisture, and moisture cools and cumulonimbus clouds are formed. So moisture has cooled down, cumulonimbus clouds are formed, and there will soon be a good amount of rainfall. Finally, thunderstorm clouds organize, and now rain bands are getting created. So this, when winds are coming in and they have started swirling around from all directions, they go up, and over there they just start becoming intensified. Their intensity has started to increase, and that's what happens. You see, initially there is a tropical disturbance, some thunderstorms. If this persists, if this goes on, then we get the tropical depression. Finally, tropical storm. Now this is where rain bands start forming. The circulatory motion starts. Now in these two, something or the else happens, like the wind speeds might get changed, or there might be some blockage coming on top which dissipates the cyclone. But if it continues, then there is a spiral rain band here. This increases into severe. Once you enter the tropical storm, spiral rain band, then there is no looking back. Then it will go into a severe tropical storm and tropical cyclone, or a hurricane, or a typhoon. And if the tropical storm creates a landfall, that is, it touches land before, then it will dissipate. But mostly it goes up till the end. Finally, stage 5, air descends at the center. Now everything is set. There is a descending calm air. There is a low pressure region is maintained, and the eye wall is the most destructive part. Extreme winds and extreme rainfall is taking place in the eye wall, and maximum winds are happening over here. Now, I would like you to see in which direction the winds are flowing. They are flowing in this direction. Okay, so I would like you to guess which hemisphere we are talking about here, northern or southern. Now, cyclone maintains its strength as soon as it receives the warm, moist air from the ocean. Finally, once the tropical storm enters land, once it starts hitting the land, then the cycle of intensification of low pressure and moving up, creating rainfall, falling down, this starts to dissipate because the low pressure area starts to weaken and the continuous supply of moisture starts getting weakened. Now once that happens, the cyclone starts dissipating. Now once the cyclone is dissipated, now we can learn about what cyclones are called in different parts of the world. In North America, they are called hurricanes. In India, they are called cyclones. In Taiwan, China, and Southeast Asia, they are called typhoons. In Australia, they are called willies. Just remember for match the following questions, not much. Now, the scale which you are seeing here is actually a Simpson scale. But in India, we don't use this scale. You must have heard about different categories. Category 1, 2, 3, 4, 5. Fifth category is the most horrible kind of a hurricane that is present. But we don't use this in India. What we used is IMD cyclone intensity. Now, the reason for that is that Saffir-Simpson scale uses a 1 minute average of wind speed. That means in 1 minute, they see that what the average of wind speed is. But in Indian conditions, this does not work. In Indian conditions, we need a bigger time lapse. So in India, we follow 3-minute rule. Sustained surface wind speed is the 3-minute average. So North Indian cyclones are smaller in size, intensify very rapidly. It is very fast that happens. And on our conditions, in Indian conditions, more destruction happens with rainfall rather than winds. So more important than winds for us is the intensity of rains that creates more destruction. So Saffir-Simpson scale measures the wind speed more, not the rains. But IMD cyclone intensity has to take in the factor that along with winds, water will also create a lot of damage. In our case, the most disturbing is the super cyclonic storm, this one. And it is very easy to learn. Earliest is the cyclonic storm, then is the severe cyclonic storm, very severe, extremely severe, and finally the super cyclone. Now let us get into anticyclone. Anticyclone is just the opposite of cyclone. Literally, it is just the opposite of cyclone. Whatever happens in cyclone, just flip it. That is the anticyclone. Number one, it does not create any kind of destruction whatsoever. Number two, there is a high pressure in between within the trough, and winds are flowing out from there instead of getting inside. Winds are flowing out, and air cools and becomes dense. Nothing much. It is so calm and so peaceful that you might be currently under an anticyclonic condition and you won't even know about it. The movement of air over here is also the opposite. Like movement of air in a tropical cyclone is anti-clockwise in Northern Hemisphere. During the case of anticyclone, it is clockwise in Northern Hemisphere. Now let us get into temperate cyclones. So when two different air masses meet, boundary zone is called a front. So this is a front. There is cold air, there is warm air. This is a front. The boundary between the two air masses is front. Now how do these air masses form? Imagine there is a piece of land with a particular temperature, pressure. Air packet on top of it will slowly start acquiring the same temperature, and that becomes the air mass. Now this complete air mass starts shifting due to some reason. So whether the land previously was warm or was it cool, that will decide whether the air mass is warm or it is a cold air mass. So two different air masses meet, boundary zone is called a front. Formation is called frontogenesis. There is a cold front, there is warm front is over here, sorry, and there is an occluded front. Occluded front comes at the last when a front finally dissipates, when the temperate cyclone is over. Then right before that comes the occluded front. Hence, we will get into more details here. So formation, extratropical cyclones form along the polar front. How can it form along the polar front? You see, there is the earth, then Okay, there is a 60 degrees north is over here, 60 degrees south is over here. If polar front is being formed here, then how come we get affected or we get to hear about severe destruction with temperate cyclone or severe rainfall happening in the northern parts of Northern America or in Europe? Why does that happen? Remember ITCZ. During the winter months, ITCZ is below in the Tropic of Capricorn. So the polar front also comes down around 40 degrees north. So polar front can easily form around 40 to 45 degrees north and south of the equator. That's where a front forms and frontogenesis starts. Now pressure drops along the front because of jet stream or any other conditions. Rossby waves is also another condition why it will a low pressure might form. Once that forms, then a circular motion begins. Now this is wrong. Cold air will not come from the equator. Cold air will be coming from the poles and warm air will be coming from the equator. So both of them will start pushing each other. So warm air from the equator starts pushing it and cold air from the Arctic starts pushing the warm air from behind. Once that starts, then an anti-clockwise motion has started and that will form us a cold front as well as a warm front. What happens in a cold front? Now, there might be a huge packet of air, warm air, but there are small packets of cold air within. There might be a huge packet of cold air with small packets of warm air within. That's why when this movement starts happening, then as the system comes across a warm front or a cold front, they change their shape, they change how they behave. Now, in a cold front, when the cold air is pushing itself towards the warm air. Cold air always pushes over towards the warm front, while the warm front easily passes over the cold air. So that is a smooth and gentle. This is a smooth process. Warm. And this is an highly abrupt process. All of a sudden this happens. So cold air advances towards the warm air. It forces warm air to rise rapidly, creating thunderstorms and rain. But this gently rises over the cold air, forming light rains and good conditions. So a little bit of sunlight as well, perhaps. So that's how cold front and warm front start fighting and start behaving with each other. Finally, what happens as the entire anti-clockwise direction comes and a circle is being formed, then the warm front completely gets over the cold front. Once that happens, then warm air is completely lifted up the front, and this is called the occluded front, and the storm dissipates. This is called frontolysis. This process of dissipation of the front is called frontolysis. Occluded front, right? Wait, let me show you. This is that over there is the occluded front. So you see, it's not completely as we must have, when we think warm air completely lifted up the cold air, we think that there is this cold over here and on top of it there is warm. No, it does not happen like that. What happens is somewhat like this. There is a warm air and it is, there are different directions. Some of it is up, some of it is down. Things are happening, but it is never like what we imagine. Completely warm air on top of cold air. No, it won't happen. It will happen somewhat like this. So over here you can see there will be tropics and equator. Over here will be the polar regions. Finally, this is where it will end. Now, some differences between temperate and tropical. All you need to know, guys, is temperate cyclone happens in mid latitudes, 30 to 60 degrees north, while tropical cyclones happens in tropical latitudes, 5 to 20 degrees north. So what is happening between 0 to 5 degrees north and south of the equator? No cyclones can form in this region. Why so? Because of Coriolis force. Now, one of the 4 reasons given for formation of tropical cyclones was the presence of Coriolis force. Coriolis force is absent on the equator and is maximum at the poles. What is the Coriolis force? The force generated by the movement of the or the rotation of the earth is the Coriolis force. So between 0 and 5 degrees, of course, it is at its minimum, and Coriolis force is extremely important for the formation of cyclones because circular motion of cyclones, remember that. Temperate cyclone winds are moving anti-clockwise and winds are also spiraling anti-clockwise and inwards towards the low pressure area. Now, are we talking about Northern Hemisphere or Southern Hemisphere? I want you to answer. The answer is, now when I say I want you to answer, I want you to pause the video as well. Northern Hemisphere, of course. And anticyclone will be clockwise. Clockwise for anticyclone. The entire system now, temperate cyclone, the entire system, okay, the winds are blowing in one direction, but the entire system has to move in some direction. What happens there? So, temperate cyclone moves west to east. So, it is controlled by mid-latitude westerlies. Now, the diagram which I always tell you to practice daily, that will come in handy in these situations. So, whatever direction the westerlies are going in, the temperate cyclone follows that because it is high up in the latitudes, beyond 30 degrees, 40 degrees north and south of the equator. So, they go from west to east. While tropical cyclone moves east to west. Why? Because of trade winds. Initially, because of trade winds. Direction of, I'm sorry. So, okay, this is the equator, and first direction is like this. So, initially it will be east to west. Tropical cyclone will go in this direction. Then it curves poleward. Why? Because of the westerlies. And that's why temperate cyclone also goes from west to east. And mostly all the cyclones dissipate around 60 degrees north and south of the equator. So it ends there. It's over. I hope you are well thorough with cyclones. It will be very important for UPSC 2026. And whatever questions you have, you can always ask me in my office hours. Next lecture we will be covering is about Europe. So remember, this is an entire series and we'll be touching Europe next. Thank you.